So last video I covered the body rig. This time we're going to be talking about all the extra stuff for the clothing. So without further ado, let's get into it. So let's start with the bag because it's probably the most straightforward of all the setups here for the clothing. So we've got this bag tweaks here which opens up all these extra little handles. We've got ones for the strap, ones for the main bag and one for this little keyring here. So the main control here obviously controls the bag. So this is what everything derives from. It's like the parent of everything. So we move this around and we can move it around freely, pull it out, whatever. Originally the bag was assigned just to the hip bone and then like the strap was assigned to like the spine bones going upward. And what this would do, I'll put it on the screen now so you can see the old kind of thing. You'll notice that the strap's kind of deforming a bit weird. That's because I didn't set up the weight painting for it, but there were issues with it anyway. Even if I set it up properly, it wouldn't really work the way I wanted it to. And then the other issue is the bag looks like it's stuck to the hip. So there's no real movement. It just looks like it's been glued to the hip and it's just shifting backwards and forwards. So I wanted the bag to feel like it was more independent. So that's why I created an actual separate rig for it. So what this means now is this main handle here is actually parented or the child of the hip bone. So it would still behave how it does on that previous preview that I showed, but we can actually move it left and right to offset it. So when we're walking now, I'll show what the walking animation looks like now. You'll see that the bag actually remains fairly central and has a bit of shift, but it makes it look like it's actually an independent object to the actual rest of the character. So from the main bone, we've got a chain of two other bones which determine the flap of the bag. So we can lift these up and open the bag like so. You'll notice that the orientation of these doesn't really matter because there's a limitation underneath on the actual deformation bone that prevents it from like shifting sideways or twisting. Now, having a bit of twist and having a bit of like left and right kind of movement probably would make sense, but because of how the weight painting and everything works, it causes a bit of deformation that I don't really like, so I've decided to limit it. But the handles, because of the way you set it up, you set that up on the meta rig, the handles don't actually adhere to this, so if I move this left and right, they just move and you create, the bones underneath will move, but the actual handles won't obey those rules. To make them obey those rules though, I can go in here, go to bone constraint, and I can add a rotation. And then I can limit on the X and Y and set this to local. And then this will now behave as expected. So I'm trying to turn it now on the Y and it won't, it'll just lock it in place. And then to add that to the other one, we kind of select like this and then copy to selected. And then this one will have the same thing and this won't do that anymore. The only problem with this is if I go into the meta rig, and I make some changes and then I update the main rig, all these like additional constraints that I've added onto the handles just disappear. So when the rig is like properly set up and ready, then I will actually put these constraints in. But at the moment, because I'm constantly updating the meta rig and I'm finding issues that like little bugs that I've missed here and there, I'm having to constantly update it. So there's no point putting these constraints in. So the next thing to talk about are the straps. So if we move this left and right, you'll see that the handles for the straps are actually moving. And then the other thing is you can move these manually to kind of get a bit more of a twist in them. Now the reason these are like this is there's situations where this sleeve, for example, when the arm moves back, the sleeve might start clipping through the strap. So by grabbing this, we can just rotate this slightly and move it out the way and stop it from clipping and avoid the ugly mess. The way this actually works is this bone here, there's two bones. There's one that's looking directly to the tail of this one here, and then the other one determines the actual handle. Because of the way Rigify works, a lot of the time you have to set up multiple bones to allow your handles to actually rotate. So that's why that works the way it does. The other thing is constraints sometimes stop you from turning handles, so you might put a constraint on a bone, but then you try and turn the handle once you create the actual rig and you can't turn it. So this setup allows me to still have the tweak capability while having this automatic like rotation to keep the strap fairly neutral. And you'll notice in the animation that I'll put on the screen now that the bag strap, I haven't really done any tweaks to it in the animation. it's just natural. So the only thing that's been animated there is the bag position. Instead of it following the hips, I've kind of made, like, orientated it a little bit. I think the only tweak I have made is at the back, because there's a few frames where the sleeve tries to clip through. So then the back just rotates out slightly. So the way this is all weight painted is up here we've got the shoulder bone, so that's the top half of the strap is assigned to that, and then we've got a spine here, so the spine comes down here with the weight paint and then down here at the back, and then the actual strap starts. So there's a bone here and a bone here, and then there's like an even distribution between the two, which allows this nice curve that you get. This one's a little bit funky, you can see that it is pulling in a little bit. That's probably because of there's like a bit of an influence from the breastbone, so that's what's causing that. Now, if I hadn't done it this way, you'd have to assign the bag and this part of the strap to the hips, and then there's a spine bone in the middle here. I don't know if there's 2 or 3, I can't remember, but you'd have like this part of the strap then to that bone, and then as we go up, we've got the shoulder and the upper spine. We'll have to assign that. But what would happen is when the shoulders turn one way and then the hips turn another way, you get a twist in the spine, and then you'll also get a weird twist in the strap, and it won't look very natural. It won't look like it's an independent entity from the rest of the clothing. So by actually adding a bag rig, that was the only way I could make it feel independent. And then the other thing we've got is this for the little keyring thing, so I can actually add physics to this and move it around. So moving on to the skirt, if I press this button here, we get these little tweak bones essentially. So these little spheres each represent a bone in the skirt. As you can see, there is a lot of bones in the skirt. When I rotate this one down here, we kind of get this part of the skirt, and then I rotate this one, and then you get, because they're like in a chain, because if I move this one, they all kind of move together. You'll also notice that as I rotate this, it feels like the skirt's getting longer and stretching. I'll talk about that in a little bit, because there's a really important thing you have to kind of consider when like animating skirts, and that is like when you lift the leg and the skirt is kind of dropping down like the leg, you can't just rotate the bones. It ends up creating like this weird stretching effect, and it looks like these skirts getting way too long. What you can also do with these though is you can scale them. You can scale them like however you want, and you can obviously rotate, but you can also grab them and pull them. So the whole point of these tweak bones is basically to tweak. So there'll be situations where the leg will be clipping through the dress, which I'll show in a second, where you will want to like rotate this out of the way. So we've got the leg IK here now, so we can show what happens when the leg is lifted, and you'll see that the skirt automatically moves. And this also works with when going backwards. And then it's also exactly the same for the side. Now, in extreme poses, like sitting down or doing the splits, there is an issue where when we go all the way up like this, you start to get clipping, and if you keep going even further, it will start to clip through the top. Now this is very difficult to fix, like with an actual automated system that this is, but because of the tweak bones, we can easily fix this by just pulling this slightly out or rotating it slightly out, and then adjusting this slightly to kind of hide that bit of clipping. So in a walking animation, maybe there'll be a point where the leg just slightly clips through, or it like round by the knee, maybe it clips through a little bit. With these tweak bones, I can put in some little extra keyframes that just fix the skirt. There is also something else that I've added, which is the cloth physics, which also fixes a lot of these issues, but I'll go into that a little bit later on. The other reason why some of this clipping happens is actually because of the typology. So if I would just put this wireframe on, see that the typology goes down this way, and it's the same with the leg, which is fine for like when you're doing this. And the skirt, as things rotate, this typology kind of changes angle slightly, but the leg is going at that angle. And then as you go further and further up, you'll notice now the typology of the leg is pointing that way, and then the typology of the skirt is pointing this way, and that's why you end up with clipping like this anyway. it's very difficult to fix it, especially with this skirt design, because there's a bit of a pleat here where it comes in. So again, just the tweak bones will fix it. That's why they exist. So what we're looking at right now is called the meta rig. This is where you set up all your bone constraints and all your other settings so that you can then generate your full rig that has all the handles and everything. So this is where you do all the work, and then you go to here, there's like a button down here somewhere where you regenerate rig, and then this goes to like the main rig with all the handles and whatever. That's where we do all the work. I'm showing it here because it's probably going to be easier to show here, whereas if I do it in the main rig, because there's so many different layers for where all the bones are, it's very difficult to find the actual stuff to show it off properly. So I'm going to show it here. So I know there's a lot going on here, so I'll try and break it down and explain it. I'm not going to go too crazy on all the constraints because there's so much going on here that it kind of, I've almost forgot all the stuff I had to do to get this to work. So here we've got the thigh bone. When we rotate this, the skirt moves, as I demonstrated earlier. But what's going on here is there's 2 extra bones inside each thigh, so these little ones here that I can't click on very easily. Then there's one at the side here, and then there's one down by the knee. Now if we start with the one down by the knee, when we rotate this, you'll see that it will start to follow, and then we go back and then it will start to follow. And there's always like a limited distance that it will follow at. The same if we go sideways, it will stay there in place, and then when we get so far it starts to pull. And you'll notice that the moment it starts to move is the moment the skirt starts to move. That kind of gives you an insight into what's going on here. On this bone there is a limit distance, so that's why it follows the bone. When it's at 0.8 meters away, then it will start to move. That's basically what's going on here. In conjunction with this, we've got these 2 bones in the middle here that are very difficult to see. We'll start with this smaller one here, and I'll see if we can kind of see what's going on. When we rotate here, you'll see that this little bone is now moving and shrinking. This one's the one we're talking about right here. It's kind of getting longer and it's rotating with everything. But you'll notice that it doesn't rotate until we hit that threshold, and then it'll start to move. So what this one has on it is a damp track and a limit rotation. So the damp track is what tells it to look at this bone here. It's basically like point down at this bone and follow it. So if I just zoom out a little bit, you should be able to see that it is just pointing directly down to here. Now the limit rotation stops this from going backwards. So if we move this now backwards, that little bone doesn't move at all. The little bone is here, right? It's still in the same place. Whereas we end up then pulling this other bone, which is the bigger one, and then this one also shifts and scales. So what we've basically got here is a bone, the little bone here, this is for forward movement, and then the little bone here, which is for back movement. What you'll also find is if we rotate sideways, both of them move together. That's because the skirt bones at the front and the skirt bones at the back will both use sideward rotation, but they'll only use forward for the front bones and backward for the back bones. I hope this is making sense because it is kind of complicated. Then the other thing we've got is when we rotate like this, we've now got this bone at the side that is also shrinking, and this is our scale control for sideward movement. What these bones in here actually are doing is they're holding all the information for the outer skirt bones to follow. So these will have a bunch of constraints. You've got XY rotation, Z rotation, you've got scale forward and scale side. So for example, when rotating to the side, this bone here is scaling, and that is the scale side, which this constraint is doing. So when we're rotating sideways, these bones are actually scaling ever so slightly. They're getting smaller and smaller. And then the same when we're going forward, these bones again are getting ever so slightly smaller. The reason they're doing that is if they didn't, when the leg lifts, the skirt will look like it's being elongated as it rotates, even though it isn't. It gives you the impression that it's getting longer. So by adding this scale, we bring the mesh, we kind of scale the mesh down slightly so it doesn't look like it's getting really long and elongated and looking really strange. And obviously the rotation of each of these bones, there's different distributions, which is copying from this little bone in the middle here to make this rotate this much, or rotate, this is only rotating a slight amount and this one's rotating a little bit, right? So that's what's going on there. Now this chain here will use these controls to determine its position, but for the middle chain is actually using the two chains either side of it. So this chain here and then this chain here is using those to determine its rotation. So what you'll find is when I rotate this forward like this at an extreme amount, this one's rotated fully, whereas this one's only like rotated about 50% of this one. Now, if I were to go into here and I will then enable the other leg, if I do the same here, you'll notice now this one in the middle has met this one here because it's now taken 50% from the other side. And if I were to pull it down, it will create this arc situation that we've got here. This is exactly the same for the side bones. And this is taking all of these here and all of these here. So when we rotate forward, you'll see that this gets a bit of a curve here. But obviously there's like no like other leg situation here. It's actually just taking all the information from this one and all the information from this one and just like rotating slightly. Now originally when I set this up, when this leg would go forward, these at the back would also use some of the rotation and go like this to kind of keep this chain, this like, I don't know, this arc of the skirt, kind of keep it consistent. But the issue I found is by doing it that way, you would end up with like this problem where it would constantly clip into the back of like the backside. Basically it would clip through, and without creating another two bones that determine all the information and adding loads more constraints, I wouldn't be able to kind of separate how much the rotation was. So I ended up deciding I'm just going to use two bones and have with a limiter, so there's one bone for the forward and one bone for the back, so then when this rotates forward this just stays in place. And the way I get around the physics side of that, because really this should be kind of, because this material's pulling this way, this should technically be getting pulled slightly like that. The way I get around that, I'll show that next. So the final piece of this is actually cloth physics. So what you're looking at here is called cloth pin, which is how much of the cloth stays in place compared to how much is allowed to move freely. So we've got red at the top and then we've got blue at the bottom. So the more red it is, the more it's going to stay in position, and there's going to be more influence of the bones that we've got, all these bones here. There's going to be more influence on those than there's going to be to the stuff at the bottom, right? So what you'll see is up here, this is kind of barely moving, but down here we've got a lot more movement going on. And you'll see that the bones do still move forward, and it causes this kind of like puffing of the skirt. So what we've kind of got here is a mixed kind of physics system going on. We've got animation underneath of the skirt moving. As the leg moves forward, it's kind of pushing it forward. And then we've got cloth physics that cause it to gently like swish. And it also fixes a bit of the issue at the back. So when this leg kind of comes forward, this will naturally drop down anyway. And then as it goes backward, you see there's a bit of a swish there as the leg kind of pushes it back. Now, as you add cloth physics, what ends up happening is the strength or the influence of the bones becomes less, because now the cloth physics start to take over. So that's why this isn't completely blue. It's kind of like a bit more a like tealy blue kind of color. That said, there's still a bit of influence from the bone. However, when you have this activated, it does cause some like clipping issues, so that you have to create collision to solve that. So what we've got here are a couple of colliders. So we've got this weird cylinder one that kind of fattens out in the middle. This is for the thigh, and then we got this weird bowl which is for the buttocks. If I turn the clothing back on, you'll see that what these are doing is when they collide with the cloth, they will push it out the way. So these are basically colliders, and then this is what interacts with the cloth. So this is hidden underneath. Doing this in Unreal, there's a different way of doing it, but it's still the same kind of principle. You set up colliders and you assign them to the character's bones, and then you can make the cloth physics work. And this is what it looks like on the actual character. You'll see that it's vaguely within the shape. It's not perfect, but it prevents any clipping through the skirt. So if I go into the physics tab here and I press this button here, it will turn the cloth physics off. So the first thing you'll notice is the animation's suddenly gone a lot quicker. That's because it's not having to calculate all the cloth physics. But we've basically just got these slight little bumps from like the legs moving forward. But then when we turn it on, it suddenly just kind of brings everything to life. So we've still got this little push happening, and a bit at the back as well. We've still got all that happening, but we've also got this like natural movement of the skirt. So it's kind of like a nice little hybrid between the two of them. And now on to the most complicated part of the rig, which is these little ruffles here. So if I just hide this for now, and we're talking about this part of the clothing. This is part of the meta rig that I'm showing here to kind of, it's very complicated. It looks, as you can see, there's a lot of bones and a lot of things going on. You've got these control bones up here. You've got this bone here, which is a bendy bone, which I'll show it in a minute. Then you've got these little bones here, which are actually the deformation bones. And then you've got a bunch of control bones around as well. So it might seem like it's overkill, but trust me, I tried so many different methods, and this was the best one I could actually come up with. Originally, I just did normal weight painting, but the problem is you assign, say, the top of the sleeve, like round here, to the upper arm. And then when the upper arm twists, all of this underneath, so if I just get rid of this, all of this underneath will then bunch up, and it will just look ugly, and it will all deform weird. You'd get like this clipping through the back, you'd get this clipping through the front. It was just horrible. So this is the second method I tried. So as you can see, there's a lot of bones here. We've got all these control bones here. We've got all these which are like our deformation bones. If you move this down, you'll notice that they all kind of compress, and you move it forward and they kind of all spread out, and it works. But the problem is when you kind of close this down, you get a lot of bunching at the back of the mesh. And there's certain poses that I'm finding hard to recreate it, but there were certain poses that when you kind of twist and rotate, that everything would just fly out of whack. And then I was getting a lot of issues with the front as well. Like when I started putting the front in, that was where I was like kind of pulling my hair out and going, this is just taking me so long to try and work this out. I need to come up with another method. So I kind of slept on it, and then I came up with another method, which is the method that I ended up sticking with. This might look complicated, and that's because it is kind of complicated, but don't worry, I'll try and explain it. If we go to B-bone here, you'll notice that now it's super clean, and there are 5 bones here. These are parented to 5 bones underneath, which all have constraints on them. And then we hide those, and then underneath we've got another 5 bones, but actually it's a single bone. That's because it's a B-bone, or a bendy bone. And a bendy bone is exclusive to Blender. You can't bring bendy bones over into Unreal because, well, they just don't work. Whereas in Blender, they're treated as whatever segments you set. So you can have a long bone, and you can set how many segments you want for it, and it will actually bend. And these two on the end are actually controls that you rotate them, and it will determine the angle of the bendy bone. So you can see, like, if we do this, the bendy bone kind of does this arc in motion. Because they don't work in Unreal, I had to basically create a system that mimics a bendy bone by using a bendy bone. So it sounds a bit ridiculous, right? Because it is. but it works. We've got these 5 bones, which are all individual bones. These are all parented to bones that have constraints on. Again, the reason I've done this is so that the handles for the tweak bones, which I'll show in a minute when I actually show the actual proper rig and show you how it all works, it allows us to then have these individual tweak bones so we can move them independently of the actual system that's working underneath. Otherwise, they'll just be locked in place, or you also get this issue where you have the handles, they misalign with like the mesh, so you can't really get a proper visual like feedback of where you're tweaking and stuff. So I've had to set up 2 layers of bones to make that work. So what these do is, in their constraints, they've got a armature constraint, and you add a target bone to it, and then that here, you point this over to that bendy bone that's underneath, this like slim little thing underneath, right? And what that does is it makes this bone rotate based on where the bendy bone's like kind of rotating. And then they also have a damp track, and the damp track points to the next bone in the chain, and then this one will have a damp track that points to the next bone in the chain, and so on and so forth up to the control on the end. Now, to actually set up this bone, I had to set it up straight, right? So I have to have this as like a flat bone like this, and then one that comes up, which is the bendy bone, and then another with control on the top. And then I had to then build all these bones in between and set it all up straight. And then in pose mode, I would move it over, pose these 2 end pieces, so it then rotates and gets that nice curve. And then I would actually, I think it's Control A, and then I'd apply pose as rest pose, and then that would then fix it in place. So it's a bit of a weird workaround you have to do to actually make the whole structure work. The bones on top, these don't have any constraints on them, but they're simply parented to the one underneath. And these are your deformation bones, so these are what the actual mesh are assigned to. But that's not all, because there's a little bit more going on in here, and there's this bone here, which is actually our sleeve slide bone. So what this does is when the arm comes down, it slides down the arm. So you see it starts here, and then it slides its way down to here. And these bendy bone things are all parented to this. So these controls here are parented to it. So then they pull their way down along the sleeve. So obviously what this does is when the arm slips down, the sleeve slips down, as you would expect it to. And then when you raise the arm, it doesn't move at all, it stays on the shoulder. This also means when we move it forward, it slides slightly forward. And if we rotate on the y-axis, you'll notice something, that this arm is actually rotating, but this inside is not rotating at all. This brings me on to what these 2 bones are. When I lift this up and lift it down and lift it forward, you'll notice that this bone is rotating. But if I press Y and do local Y and rotate it, this one is no longer moving, but this one up here is rotating. So what I've done here is I've got the X and the Z assigned to this bone. So any rotation of the arm is all here on just the X and the Z. And then this one at the top only takes the Y rotation of the arm. So I'm putting this in afterwards because I didn't really explain it very well. These 2 are actually like reference bones, so they're collecting information from the shoulder and the upper arm. This is like ignoring the Y rotation on purpose, because what we want to do is this bone here inside the arm, when the arm lowers, we want it to rotate on the X and Z axis, and when you lift it and whatever, we want it to keep that orientation, but we don't want it to completely follow the orientation of the arm. We want to remove the twist. So you'll see later on when I kind of demonstrate like the actual rig, that the arm can actually twist while keeping the sleeve in place. And that's why I've had to separate all this like information out and put them into 2 control bones. The other thing with this is this also inherits the shoulder, right? So when the shoulder moves, this moves. So when the shoulder's down like this, you'll notice the arm's down at this angle, so this is moved as well. And then we move this down and this is down. Now you can actually do this through constraint where you set it's like local with parent, but the problem with local with parent is it will also take the spine, and when the spine rotates, it would cause this to rotate as well. Whereas the way I've done it is I made it so, I think this has 2 constraints on it. Yeah, so it's got the shoulder, inherits from the shoulder, and then it inherits from the upper arm. So it's not inheriting from the spine as well, which was one of the major issues I was running into with trying to get this all to work. When this goes like this, what would happen is this would slide down the arm, which is not what we want. We want it to only slide down when the shoulder drops down and when the arm drops down. Now, how does this differ from the second method? Well, when we do this, you'll notice that these bones now all kind of compress, so they scale inward. And what that allows is the actual mesh to not kind of overlap each other and bundle up. It kind of instead compresses a little bit. And you don't really notice it too much in the animation, but it just looks so much neater. So let's look at how this actually looks on the actual rig with all the handles. So over here we've got sleeves, which are these little things. These are like just our main controls. So we can kind of move this, so we can rotate this, and it determines like the direction the bendy bones work. So what I was showing earlier is the little end point. The other thing we've got is we've got a control here that we can move left and right. This just moves the sleeves around a little bit. So if I grab the arm like this and pull it down, you'll see that it slides down. You'll notice there's a bit of clip in here. That's because of how I've set up the shoulder. There's that little shoulder correction, and it pulls the mesh down a little bit, and it ends up going into the sleeve a little bit. So to fix that is I've got this little tweak bone here so that we can just move this out a little bit and fix that issue. So it's not a major change. To automate this would just be a pain in the ass. So I've just made it so I can just manually do it where I need to. Now the benefit of this is when we pull it down, obviously it will slide down the arm. But if we were to press on the y-axis like this and start trying to rotate the arm, you'll notice that the sleeve stays relatively in place. Obviously there's clipping, we just fix this by doing this, right? It's not a big deal, we'll just rotate this a little bit and just tweak it a little bit. But it means that the sleeve actually acts almost independently of the arm while still having a bit of automation. So then when we shift this like up like this, if I just reset it, we shift it forward like this, it's relatively not too bad. And then we've just got to do a little bit of tweaking like here and there, like pull this out a little bit, maybe tweak this around. You have to be careful that you're not clipping here instead. And again, it's the same with the back. So if we you can pull it up, and sometimes you get like this looks like it's spreading out a little bit too much, and the way you would fix that is you just rotate this, and then you can just, there's a bit of clip in here, so if we just rotate this like this, pull this out a little bit, there you go. So just with these controls alone, you've got quite a lot of customization and a lot of control over this. You can again pull this up like this and rotate it. Because the way the bendy bone works, it just creates like a natural arc for everything. When we pull this down, you'll see that it just compresses quite nicely. There's a bit of a curve here, but you can, like, if you want, just rotate this and kind of get a bit of that curve out. A lot of that is down to weight painting as well. But what we've also got is this tweak button here. We press this and we get these little orbs again. So these are just like little fine tweaks, so you can pull the sleeve out a little bit. They have a little bit of limitation because there's a bit of rotation that happens. Generally, I don't think these are going to be needed. Now that I've kind of messed with these a little bit, I don't think they're really that necessary, but they're there if I need them. And that probably concludes all the clothing rig additions. I was going to go over the animation, but the problem is this video is probably already getting pretty long. And I'm doing live commentary this time instead of like pre-scripting everything, just as an experiment to see how it turns out. Let me know in the comments if you feel this still works. The problem with like doing an actual edited video is you've got to do all the steps and then kind of combine them all together. Whereas if you just do live commentary, you hit all the steps in one go But the problem is then my actual talking isn't as clear and it isn't as concise, and I'll tend to ramble quite a lot and just go off on tangents. So let me know what you think of this type of video. So if you like the video, leave a like, leave a comment, do all the things that the YouTube algorithm loves and help me along. You can also follow me on Patreon, where I have images, videos, and full write-ups of everything I've been up to that week. I do it every Monday, so you can follow me there and get all that information. Because I'm only like posting videos every like month or month and a half, it's like you get to kind of see the little bits in between, and the weeks where I just decide that I'm going to be lazy and do absolutely nothing, and I'll say, sorry guys, I've done nothing this week. And if you want to do none of that, would you kindly bugger off?